Welcome to this UASMaster video tutorial. Today we just want to focus on a function which is existing in the type point extraction of UASMaster, and we want to take a closer look to approximate, initial orientation, precise, and weak. With precise, we assume we already have a good kappa rotation for the photos. With weak, we can determine the kappa rotation for the photos. We will showcase this with an example, and hopefully this will help to explain you the function in more detail. We will load a dataset, a DJI Phantom 4 RTK dataset, and after the import we can then see how the photo rotation is displayed. We extract the GNSS from the images and add the camera from the EXIF too. We can see here that we don't have IMU information, but just GNSS, and as a RTK we enhance here the accuracy for X, Y, and Z. Here we go. We have now for all the photos the GNSS data imported, but we don't have any IMU information and at the moment no strip information, and therefore all the photos are north orientated existing. You can also take a look how the photos are displayed in the georeferencing module, where in the topo view we can see for each photo how UASMaster assumes that it's positioned. You can find the topo viewer here on top. It loads each photo as a separate one. We activate all the photos, and when we activate them with a specific zoom in, then they will display it. We can change here the size, and then we see that they don't fit to each other. Yeah, so here on this side these two, yes, but the street here is not concurrent with this one here. The rotations are not correct to each other. We can also see it here. The soccer field here is pointing this way, on this one it's pointing this way. So this will then cause trouble when we assume this is a precise orientation. And this is perhaps also the issue. So when we close topo view and we try to run this whole thing on precise, then the process will fail. Let's take a look, and I will show it after it fails. So here we see already warnings that some photos are rejected, and then after he tries now to get more and more points, it will see that it's not possible to get the points, and then the blunder detection will show us the errors that we don't have enough connectivity in the block. There are two solutions. We can either move from precise to weak, so we could here change this one here to the weak one. The weak one includes a more complex structure for motion algorithm, and it will solve the rotation and take care that then the photos correctly fit to each other. Another option is to try to give a better initialization through strip definitions. So we could here go away from the georeference part, go back into the project editor. In the project editor we can define strips. They can be done automatically, and then after the strips are defined we can also look if there are some photos remaining. We see this photo is not part of one. Normally you would need now to check. I already know now this one here belongs to this first one here, so we can edit and say add this one here to this one here. And so we can add this one, so all the photos have now a strip relation. And with the strip relation, I can save here the project. Then we have now the strip information. And now we can say, okay, apply the kappa values, which we can get from the strips, to the photos. So we go to the photos, we select them all, we go into edit and say, okay, initialize now with strip information. And then right before I do it. So here at the moment, all the kappa values are 0. And then we can here initialize from the strip. And now each photo has its own kappa value from the strip. Yeah, so then we can here save it. And then we can now see here the photos have been rotated. And when we go into the georeferencing and take a look into the topo viewer, we can now see better how UASMaster is handling the photos. And I will just zoom here into large. And now we can see that they are now better rotated to each other. There's still one photo here remaining. This one here which is applied to this strip, and it should be normally part of this strip. But we will run it and see if it works. If not, then we can apply this photo to this strip and run it with the precise one. Precise has the advantage then that from the type point amount, we'll need less type points still to reach to a good result. If you go to weak, then we need more type points to solve this rotation, which is also possible. One thing would be, for example, if you go for weak, that you increase the to high level where you get normally in the higher resolution more type points, and then this would then also be a good solution. Both ways are fine for us. Main goal here is type point extraction. It's not about camera calibration. I did not measure any control points at the moment here. And also there are, in this block here, there's a GNSS shift also, so it will not look nice, but type points is what we want to get. So we want to reach a part. So I will try now again with precise, as we did. I think I have already predefined this one here. So precise with GNSS. And now we rerun it. And hopefully now before it failed, and this time it won't fail. And then we can continue then with our processing as typical in the georeferencing with control point measurements, camera calibration, and the final product then continuing with the point clouds and orthophotos. So here we go, and the process was successful, which is nice. We have now type points in each of the photos here, and therefore now we could continue to solve our orientation part. I hope the video helped you to work with UASMaster better and to understand the approximate initial orientation parameter in a better way. See you, goodbye.